Now we're going to do 2004 AB question number 1, Form B, and we're going to do the C question. And in this case, let's draw this out. Curve looks like this. It comes down at x equals 10, and in this particular situation, this is also the rotational axis, which means your graph should be coming out to here. This makes it very easy to visualize disks. If this is your rotational axis, remember this is x equals 10, not x equals 0 or the y-axis, then you should realize that you're going to have a disk that comes down like this. It's going to be completely filled. You'll have another disk that'll be completely filled. You'll have another disk completely filled. And each disk's radius is going to have to be based off a position on y. Because this radius is going to be larger on the bottom. The radius is going to be 9 when y equaled 0. And up here, the radius is equal to 0 when y equaled 3. And so that means, as this is going to be a dy problem for disk, and it's not really a washer method, but I'll write that down, disk washer, dy, very simply, the fact is y equals the square root of x, minus 1. Y squared would equal x minus 1. Y squared plus 1 would equal x. That's going to be used to help us determine a radius. But there's a catch. The radius comes out this way. Radius is this piece. This distance is the x. Or, if you want to look at this radius, I guess you could say it's the function based on y. So once again, we have a relationship where we need to add the f of y plus the radius at y, and it's going to have to equal the total distance between here and here, which is a constant 10. Therefore, the radius y is going to equal 10 minus f of y. But since f of y, or in this case, was determined to be quantity y squared plus 1, that is going to be our radius with respect to y. So, if I am setting up this particular problem, yeah, that's it. I'm just momentarily thought there for a second. Let's try this again. The integral goes from pi. Now remember, this is a dy problem, so it's 0 to 3. Your radius is going to be 10 minus y squared plus 1, and this whole thing is going to be squared, and it'll be dy. I would hate to, and this is what I was just verifying, is that I would hate to see you make any mistakes foiling this out, thinking it would be 100 minus this. So remember, 10 minus this is actually 9 minus y squared, dy. So if you wanted to work it out, you'd actually have 9 squared minus 2 times 9 times y squared minus y to the 4th dy, which means the integral would go from 0 to 3 of 81 minus 18y squared. Oops, this is a plus y to the 4th. Negative y squared plus times the negative y squared is positive y for the 4th. Therefore, positive y to the 4th dy. That is something that could easily be worked on and continue to solve. And in fact, this case, what the heck, let's just do it. You're going to get the integral of 81 x squared. Now, this will become y cubed, so 18 divided by 3 would be 6. And then going to y to the 5th, that would be 15 y to the 5th, going from 0 to 3. Okay, I just realized that I'm making little dumb mistakes here because, like, the positive is supposed to be negative, this is supposed to be positive. Like, for instance, the antiderivative of 81x squared is just 81 times x. So, let's fix that up. Okay, well, I took a pause there. I confirm that if I go 81 times 3 minus 6 times 3 cubed plus 1/5 times 3 to the 5th, which then, of course, will all be subtracted by 0 being plugged in. This is 243. 3, 9, 27. 27 times 6, I believe, was 162. And 3 to the 5th is 243 fifths. And this all worked out to be 129.6 pi, because all these were multiplied by pi. And that's how you get, that is your final answer for C. Now that's assuming that you used the disc washer method. If you chose to do the cylindrical shell method, the nice advantage of this one is that you can go back and think of this as a dx problem. What you need to also realize is that you have an axis here. There's your axis. And your shells are going to start off really, really narrow and really, really tall. Okay? So right here, your radius. When the radius is 0, it's extremely tall. The farther out you go, the more your shells decrease in size. And as you keep going out further and further still, you come out to here. And yet still. So it kind of looks like stacked birthday cakes or tubes. To the point where you're on the bottom, all it's going to be is just a flat surface. So, as I'm looking at this, each radius is figured out based on a position of x. Again, your radius up here, I'm going back to the top, your radius on top is emanating this way or this way. So is it here. This is your radius. Okay, but now, if you look at it from here, if this is your line, which is x equals 10, and your radius comes out yay far, we'll call that r of x. Once again, x this way is going to help you determine where you are in terms of finding your radius. Because since the distance is always equal to 10, it really doesn't change from here to here. Once again, you have a function based on x plus r of x equaling 10, except rf of x happens to be exactly x. So that means your radius, r of x, is going to equal 10 minus x. Now, that's how you find your radius. If you're going to find your heights, realize that this curve here, going back to the top graph, is always going to be your upper height. And so your upper is always based on whatever f of x is, which in this case is x minus 1. Your lower is right here, which happens to be always equal to 0. How about if I change f to the letter h? Okay, so if I'm going to take my upper and lower heights, I can put this all together and say h of x is always going to equal radical x minus 1. Therefore, the integral of a cylindrical shell method is going to be 2 pi times the value from 1 to 10, because that's where we want to start our graph. We're going to multiply it by the radius, because this again is the surface area of a cylindrical shell, and 2 pi times the radius, which we've established to be 10 minus x, which will then subtract by the heights. In this case is literally radical x minus 1 minus 0 dx. And so that equals to 2 pi times 10 minus x times radical x minus 1. That's all inside the radical. Dx as it goes from 1 to 10. Unfortunately, I've ran out of room, but you could do u substitution, although I will say this. You may need to see video number, I believe it's 6, to kind of give you an idea on how to handle this U substitution, which is why this makes an excellent calculator question. And when you're all done, you should still come up with 129.6 pi, which is approximately 407.150. And that brings us to the end of 2004 AB question number 1.